Hello everyone, welcome back to my channel for another video. In today's video, I will show you how you can use Google Colab, Python and Umpire to create a 3D printed Lithopane. A Lithopane will be familiar to anyone into 3D printing, but for those who don't know anything about 3D printing, let me explain quickly. A Lithopane is a thin sheet of plastic or any other translucent material that is engraved or molded to allow various amounts of light to shine through. This is achieved by building up the picture in different heights. When a light source is put behind the picture, the lower parts will let more light go through and appear lighter on the image. The higher spots will be darker, and that means the picture under normal light can look quite strange or not recognizable at all. Only after a light is put behind, the image becomes visible and clear. Google Colab is a free tool from Google that allows you to run Python code in your browser without needing to set up a local development environment. It is very similar to a Jupyter notebook, if you've used one, except that it runs on Google servers. You also have access to Google's powerful GPUs, called TPUs, that use Google's proprietary hardware, which was specifically designed to handle machine learning jobs. So you can see in your screen the actual notebook I created in Google Colab. This is actually in GitHub at the moment, so you can actually access this notebook if you look at the link down in the description. So I'm going to open this notebook, and now I'm in Google Colab. So the idea of this notebook is I upload a bunch of images, in this case 5 images, 1 for the top and 4 for the sides, and then this notebook will create me a lamp Lithopane, which I then can use, which I'll show you an example of how I actually created a Lithopane and made it into a bedside lamp. So you can actually upload files into Google Colab. So they've developed some libraries for that, called some Python libraries that you can import using google.colab. I'm going to import these pictures into Google Colab. So I'm doing it programmatically, but you can also do it via the left hand side. So in this notebook, I take the images, which I'm uploading them right now. In the Python code, I convert them to grayscale. So the images I'm uploading, actually they are full color, so they are RGB in RGB format. So I take the grayscale version, and this grayscale version will have a bunch of pixels with the light intensity from 0 to 255, and using those values I will create a Lithopane. So basically the higher areas in a Lithopane will be the pixels with the higher light intensity, and the lower areas will be the ones with the low light intensity, closer to 0. You actually can do opposite way as well. So there's there's a choice there. So I've uploaded the images. I need the NumPy, but NumPy is already installed by default in Google Colab, so I don't have to install that. But I do need to install the NumPy STL library and the Bezier library. The NumPy STL library is needed to generate STL files, and STL files are files that are normally created by a 3D modeling tool. So typically applications like Blender will be able to open this file, and you can actually change them, or you can actually use the STL files and, for example, import them to Cura, which is a software used by people into 3D printing, and convert it into and convert the STL into G code, and the G code will then be used to print the object. Google Colab is a free tool from Google, and it allows you to run Python code in your browser without needing to set up a local development environment. It is very similar to a Jupyter notebook, except that it runs directly on Google servers. You also have access to Google's powerful GPUs, called TPUs, that use Google's proprietary hardware, which was specifically designed to handle machine learning jobs. So I'm going to install the two libraries I need. Now I need to load the math functions I created. Simple math functions to calculate the distance between 2 points, and also a math function to calculate the angle between 2 points. And then another function I've created to rotate a point in the two-dimensional axis in the two-dimensional plane. So I'm going to load those. So next section is I'm converting an image to a NumPy array. As I explained earlier, I first convert the image into grayscale, and then from the grayscale I can actually take the light intensities, and that will give me the heights of each point in the Lithopane. So I'm going to go in more detail afterwards in regards to these functions. Just going to load them for now. This is an example of how I'm actually. This block here was just for me to test the padding functionality. The idea is I can give it an image of any size, and then it will add some padding to make the image compatible with other images I provided. You can see here, we add some padding at the top and the bottom. If I had changed this to, I don't know, let me see, I'll make it a square. I think it's supposed to be a square, so if I make it a square, it will not add any padding. But let's say I want to make it, I think this is, yeah, so you see the padding, because I make it wider, the padding goes to the left and to the right. So this is the main function, which creates a lamp using the images that I've provided that I've uploaded previously. So it takes 5 images, 1 for the top, and then the 4 for the sides. And then I give it a width and a height. And using these padding functions, it will make sure the images will fit in. So this block here was actually just for testing, for me to understand how Bezier curves work. So if you don't know a Bezier curve is a parametric curve used in computer graphics. And the curve is related to the Bernstein polynomial. It is named after Pierre Bezier, who used it in the 60s for designing curves for the bodywork of Renault cars. Other uses include the design of computer phones and animation, and Bezier curves can be combined to form a Bezier spline or generalized higher dimensions to form Bezier surfaces. The Bezier triangle is a special case of the latter. Okay, as you can see, the way I define a Bezier curve is simple. I specify a left point and then a right point. Yeah, this is left and this is right. Then I specify a limit at the top. So for example, in this case, I specify a 0.5. So there's a line here, invisible line, which the curve can't go past. So here, this is a block which I use just to test creating a bevel for the Lithopane using the Bezier curves. Right, so I'm going to create the lamp and I'm going to try and explain some of the functions you see here. So let's see, create lamp. So for each lamp there is a Lithopane. I create a Lithopane for each side of the lamp. Okay. So you can see here where we load the image and we straight away convert it to grayscale. We resize it according to the dimensions of the Lithopane, and then we convert it into an Umpire array. Basically, this will be a bunch of numbers from 0 to 255. So normally a Lithopane, has a minimum width, a minimum depth. Or let's say thickness, and the reason is because if you are strict about 0 to 255, 0 means there is like no depth, right? So you need to give a minimum thickness to the Lithopane, and that's what I'm doing here. And you also have to have a maximum thickness. So for each side of the Lithopane, so a Lithopane is basically, you can think about it in as a big cube. So let me just try and draw it. So what do I mean with a Lithopane? So let's say this is the full lamp first, so we get an idea of what I'm doing here. So the algorithm is doing it considers each side. The top is a Lithopane, the side here on the right is a Lithopane, this side is also Lithopane, and so on. Okay, so this is the overall lamp. So I'm just going to erase it. Oh, I don't need to erase it actually. So for one Lithopane, it's easier to visualize it. There's still some, it's not just like, it has some thickness, right? Okay. Okay. The idea is that this is not just flat. Each point in this Lithopane will have a different height, and this height will be dependent on the light intensity of the image. Because of that, right, there will be a minimum height and a maximum height. So what we do, we basically calculate all these heights for the Lithopane, and then once we have the heights, then we work out the other vertices and we create mesh. A mesh is basically nothing more than a list of vertices connected together. And you can connect these vertices in different ways. In this case, I've decided to use triangles, which is very normal in computer graphics. So for one Lithopane, you have the left hand side, you have the right hand side, you have the top and the bottom, and that's what we're doing here. We're creating the edges. And the edges in this Lithopane case are not just normal edges, they are like rounded using Bezier curves. Yeah. So that's why we had to create a bevel mesh here. So if I show you how I create a mesh, we can go to this method here. That's it. So this mesh is basically a mesh is created by joining two sets of vertices together, which is shown here, right? These are, I'm going to start again just to make it easier. So you see here, sorry, I'm just going to go back a little bit. So this is vertices 1 here, and below it's vertices 2. So this algorithm will create triangles and join these two sets of vertices together. Basically creating faces for each set of 3 vertices. And this results in a mesh. And the reason I need the triangles is because then I can, I can make the service, because some of these triangles, right, some of these points will have different heights, and you'll, based on that, it will have different, that's how you get the Lithopane. Okay, so I've kind of given you more or less an explanation of what the algorithm does. it's using NumPy, and by now my Lithopane will be created. So I created a Lithopane, so I can just check here. So here, this is my Lithopane. I'm going to download it. So if I go to Blender, so I use Blender normally to create to do 3D modeling, and Blender can actually open STL files. I'm just going to import the STL file that I've downloaded. It's not here yet. So it takes a bit of time, so let's just wait a little bit. So importing it. It's a big file. So you can see here the Lithopane. So you can see the reason I've put this side is upside down is because for 3D printing it's much easier that way. So you can see the face of Jesus there. You can see the sides. This is the idea. So I'm going to zoom in so you can see first of all, you can see here, this is the bevel mesh I created using Bezier Curves. Very simple bevel mesh, just to not have any sharp edges. And you can see here the triangles. So each face here is basically a triangle. And this is actually very normal in computer graphics. You create lots of triangles to make shapes. So if I want to print this, I can actually just use another software called, for example, Cura, and convert this into G-code. Thanks for watching. Please give the thumbs up if you liked the video and subscribe to watch more videos.